Hi from Brooklyn, everyone. Thanks for joining us today. We have a really cool show for you. I'm Erin. I'm a solutions architect here at AWS. So for most of my career, I spent it on the operations side of the house, building networks, taking servers and data centers, automating build of packages and software and deploying it. Um, and in fact, what I'm doing most of today is a combination of IoT and infrastructure automation. But I love IoT home projects, making them for myself. I love taking a microcontroller and some hardware and a little bit of code to make something physical happen. And I'm joined here today with my colleague, Tim.
Hey, Aaron. I'm Tim Madison. I'm a partner solutions architect focused on IoT. So I help companies build IoT products and solutions on AWS. So I get to see a lot of new products and dive deep into partner platforms and help them solve problems every day. I've been a software engineer for most of my career, worked on some embedded systems, and I just like building things, like you said, that interact with the real world. So IoT is a big hobby of mine.
Yeah, that's why we're doing this together. So before we get started with our guests, let's get into some quick intro topics. First of all, everybody, we've published our code. Well, we published
Finally.
our code for our first episode finally on GitHub. We have it at the AWS Samples organization under IoT All the Things Special Projects Edition GitHub repo. You should find the link in the chat. So we're really excited. We'll keep rolling out these updates and the releasing this code as we go.
Yeah, more coming soon. We put a lot of TLC into it to make sure that it's perfect for you guys when you get it. So
And so you don't have to do a lot of heavy lifting when you want to run it yourself.
exactly. So I think today we wanted to quickly talk in this section about assistive technology. I've got a family member that has autism, and we went down the route of trying to find different assistive technologies that would help them in their everyday life. And we found a couple that I'd just like to let people know about, just let them know how we use these things, and maybe it'd be useful to somebody else. So the first is a product called Proloquo to Go, and think of it as like a soundboard on an iPad. You can design your own soundboard, and it helps somebody who maybe has difficulty speaking or maybe difficulty saying certain kinds of things. Just use the iPad and press a couple of buttons and then talk to somebody. So if you've got a family member maybe with autism that isn't able to talk, this is a very handy tool to reach out to them and help them participate in conversations.
Yeah, that's really good
And
to
then the
know
other
about
thing,
because having a tablet's probably pretty accessible for most families.
oh yeah, everybody's got a tablet, and there's other assistive hardware that you can get, but it's all very expensive. And this, for the kind of people that maybe don't have insurance, or the insurance doesn't won't cover one of those devices, this is a much less expensive way to do something like that.
That's good to
The
know.
next thing I wanted to bring up is a feature that I don't know that's advertised all that much, but is the Amazon Echo drop-in. I don't know, Aaron, in my house when I was a kid, anytime my parents needed me, they'd say, "Hey, Tim, get over here." And I'd say, "What do you need?" And they'd say, "Stop screaming." And nobody could understand each other, and it was terrible.
No, my sisters and
Um,
I would always yell at each other from the other ends of the house, and then our parents would yell back, "Stop yelling at each other."
Yeah,
So yeah, we
yeah.
had the
We
same
have to. Yeah. But
thing.
so Amazon Echo drop-in, you can take your Echo devices, and you can any room that you have there, you can assign as a drop-in spot, and then you can just say,
Mhm.
assistant name, drop in on this room, and it starts like a two-way speakerphone conversation. And for somebody with autism who is not going to be really happy that you're yelling at them across the house, this is a nice way to have just a
Yeah.
normal volume conversation with somebody. But even if you don't have autism, it's nice to not get screamed at. So um, that's a
Yeah,
handy
it was
feature
a
that
little
we
startling.
use. We're starting to use now.
Yeah. Oh, that's cool. So, talking about a assistive you and I, we've talked about this before. We have worked at other companies together, and we've worked together with also other awesome colleagues. And one of the colleagues I'd like to talk about today is Bob Paradiso. He is
Mhm.
really passionate about helping people with disabilities. Some of his projects are connected, some of them aren't, but one that I thought was really cool is called an eye gaze controlled wild thing. He has it up on his website. there should be a link in the chat for it. But so a wild thing, there we have it. So the wild thing is actually a Fisher-Price battery-powered vehicle, and you can control it by joysticks on the handlebars. But in this case, for those who may have limited mobility, either in their body or just in their arms, in a way to control it, he figured out a way to do it with gaze controlling. So the person who's using the wild thing in this case can just look at where they want to go, or look at a tablet to tell it where to go, which is really amazing.
Yeah, it's really cool. I got to see one of these things. I filmed a video for Bob on an earlier version that was a full-size wheelchair for something like this, and it's really cool. You kind of just look at some buttons on the screen, and it moves around. So even if the only thing you can move is your eyes, you still have mobility options, which is really great.
Yeah.
In the spirit of building amazing things, though, our guest today makes it easier for developers to build amazing things. So let's get into it.
Yeah. It's time to bring on our guest. With us today, we have Kedar Sovani. Hello, he's the Director of Engineering Application Frameworks from Espressif Systems. Welcome. Can you tell us a little bit
Thanks.
about yourself?
Absolutely. It's exciting to be a part of this show. I'm the Director of Engineering of Application Frameworks at Espressif. I've been working with connected devices for over a decade now, and one of my primary roles here is to build application frameworks so that our customers can build products faster and launch them faster.
Yeah, that is amazing. We were saying earlier, I think on every single episode we have filmed so far, we've talked about the Espressif ESP32 microcontrollers. And so, it's kind of funny, we talk about them so much. Why do you think that they are so popular?
I think there's three reasons for this. Firstly, when both of these solutions were launched, 826X and 32, they were packed with features for the time that they were launched, and they were packed with features with an amazing price point. Secondly, it's about accessibility. We have been maintaining all our SDKs and repositories openly on GitHub, so you can just get started by doing git clone, no registrations, no NDAs. And I think what that has led to is a very vibrant community that keeps doing amazing things with these platforms and publishing tutorials and videos and workshops. So it becomes really easy for anybody who's just starting off to look for support or look for help out there, because there's so much literature that's already available. And that ends up becoming the flywheel that keeps driving us faster and faster.
Yeah, it really does.
There's
makes it a lot easier.
Great community of developers behind it. Again, like Erin said on previous shows, we've talked about it a lot and some of the cool things that people have built on top of that. I actually checked my home network, and there's a bunch of devices that I have that are production devices, smart home things that I bought that are using Espressif chips that I can tell by the MAC address. So I know that you have Daikin air conditioners, you got Philips Hue light bulbs, you have Bissell vacuum cleaners, and in the UK you've got Candy washers and dryers. So it really is the kind of product that you can put in production, and there's proof of that with your customers.
Right, certainly. We are shipping in very high volumes for these customers. So.
Oh, that's amazing to hear. You introduced yourself as the Director of Engineering for Application Frameworks, and our show is called Making It Rain with RainMaker. So what is it? What is RainMaker?
RainMaker is an end-to-end development platform. And what we've tried to do with RainMaker is to give more power to the firmware developers. And the idea being that as a firmware developer, you can express yourself in terms of what your device is and what the capabilities of those devices are in the firmware. And then the rest of the end-to-end ecosystem that we talked about, so the cloud, there's cloud pieces, there's phone applications, all of these systems adapt themselves to how you have expressed yourself in the firmware. And thus, it makes it really, really easy for you to build products which are complete in nature, because the entire platform is end-to-end. And while we continue to do this end-to-end platform, we've tried to make sure that there's enough flexibility in it that developers can get a lot of choice to pick and choose and have the kind of interacted at the kind of level that they want to.
Got it. It's a pretty big investment to build a platform like this and provide all these components open source. Was it customer requests? I'm wondering like what drove you guys to build the platform, because there are a lot of companies that wouldn't have the resources or wouldn't necessarily go down the path of building all the components that you guys have built.
Mhm.
Right. And what we've been trying to do on the firmware side is try to make it even easier for developers to build products. And we've been continuing to do that, launching different frameworks and different layers of softwares that make this easier. And as we continue to do this, work with our partners and customers, did workshops and tutorials, we realized that while this is definitely helping people, there is when it comes to building an end-to-end product, there's many other technologies that come into play. There's cloud backends, there's phone applications, and all of these are technologies in themselves that need to be learned, and then an end-to-end solution has to be built. So it still takes quite a while to do this. And with RainMaker, what we wanted to do was say, how can you take somebody from concept to production in the fastest amount of time? And that's how we said, okay, let's build something where we have all of these pieces, the cloud backends and the phone applications, but the center of control continues to be the firmware developer who's trying to get this out.
This sounds like a really helpful platform. So I heard that you had a demo for us. Let's see it in action.
Oh yeah, absolutely. So what's a IoT demo without a light? So here is a switch that we control, and this is the phone application, the ESP RainMaker phone application through which it is controlled right now. We'll go into a little bit more details later, but yeah, that's at a high level. This is what you get to do.
Got it. Yeah, we always joke about the all these demos being just turning on a light or turning on an LED or something like that. But there's a lot of plumbing that goes into making that happen. It's it might be easy to set a GPIO high or something like that, but getting the message from a mobile application all the way down to the device, making sure it arrives there and that you process it, is a lot of plumbing involved. So I see that this makes that significantly simpler.
Yes, and as I mentioned,
for that?
yeah, as I mentioned, so when I said that the rest of the components adapt themselves, so this diagram here, right? So on the left, you have this device, ESP32 device, and as a firmware developer, you typically want to say that these are the parameters of my device, right? This is the power control, this is the brightness control, and you want to say that these are my device drivers that control these parameters, right? And then in RainMaker, as I said, the rest of the system adapts. The phone application, the one that we saw in this demo right now, is saying, oh, okay, fine, this is how you expressed it in the firmware, and this is how I'm gonna show it in the phone application. So you get a toggle button for power on off, or if you have a brightness slider, you'll get a slider, and that's how the flow works. And if you look at it from a code perspective, let's look at the code here that powers this actually. So this is all the code that is really needed to do this, right? Firstly, what we've done is, and let me just go through this code. So firstly, what we've done is created a switch, because the example that we looked at was a switch. Next, what we've done is that we've added two parameters to this switch. One is a name parameter and the other is the power. So, and then the switch and the second parameter here is really the default value. So name with a default value of switch and power with a default value of off, right? Next, what we do is that add a callback. So we say that this write_underscore CB is my callback that should be called whenever any of these parameters changes. Next, we have the callback implementation itself, which looks a little bit, there. But if you really focus on it finally, you'll see that it's just those two lines there, which is the GPIO set level, where whatever value is set in the phone application, be it true or false, it just hands it over to the GPIO set level, and the light turns on or off. So that's how end to end the whole thing works.
Yeah, I hear from a lot of firmware developers, and they say that making the leap from writing firmware to learning all the cloud technology is really, really big. But that callback that you had at the bottom of the screen there is exactly what I'm talking about. Like, they know how to do string compare, they know how to parse data out, they know how to toggle GPIOs, and because you have that callback in there, they don't need to worry about the rest of those components. I think it's a huge benefit to them. So.
Yep.
Could you give us a high-level view of the components of the platform?
Yeah, let's look at a diagram which showcases these components.
Cool.
So on the left here, as we talked about, there's the RainMaker SDK, which builds in all the mechanisms for expressing your firmware in terms of the parameters that it has. It runs on IDF, which is the popular development platform that developers use with Espressif. Then we have a cloud service. What the device publishes or communicates with is this cloud service that is hosted on AWS. And finally, we have iOS and Android phone applications that we saw. These are the applications that communicate with the cloud and then eventually to the phone app, to the device. And as a developer, so you're at one end you develop firmware, and then directly on the other end you interact with those devices using the phone application.
So you have these phone apps that are actually in the App Store. So as a developer, I can just go and download the app and have it on my phone. I talk a lot about being kind of a back-end operations person, and we are notorious for loving control. So I maybe have been told that I'm a control freak sometimes, but that's okay. I like to control what I gotta control. So what if I want to use RainMaker, but I want to develop my own phone app?
Yeah, it's a fair point. And as we've worked with customers, we've realized that, right, that you wouldn't have thought of these things, but all the developers want to do things in the ways that they suit them for very rational reasons. And we've tried to make sure that we retain that flexibility in all parts of this solution. So even in the phone applications, what we've done is there are 3 ways with which you can do customizations. The code for these applications is available on GitHub. So there's an iOS app repo and Android app repo. So you can take that, customize it with your look and feel the way you like it. If you want to do something more, these repositories are also structured such that there's a separate library component and then there's a separate application wrapper. So you can just take this library and integrate it with your existing product if you have one, or build a application facade on top of this. And if you really want to build completely from scratch, then we've opened up the protocol as well. So you could read the protocol and build the entire app in the language of your choice, or with the kind of constructs that you want to have.
That's awesome.
Wow.
I love the flexibility.
Yeah, so you can do whatever you need to do. You can take out the parts and build it up any way you want to. Now, the phone application, though, for me, has a lot of stuff baked into it that I don't want to re-implement, especially for like a prototype or a demo or workshop or something that I'm doing. One of the things I'm interested in is the number one question I get from people after they've started to build a product is, how do I onboard these things? Like, I need to get it credentials and I need to get it Wi-Fi settings and all of this kind of stuff. The phone app takes care of that. Can you show us a demo of how that works?
Yeah, so if you look at right now, so this is a demo of the user onboarding process. So if you launch the phone application, then this is signing up. So the user, you sign up and get associated with RainMaker in this particular case, right? So what has happened is initially you created the 7 lines of code that we discussed earlier, and you deployed it on the device. You downloaded the app. And now you want to do 2 kinds of things, right? One is you want to create a user with RainMaker so that you know that who is interacting with the device. And second is you want to onboard the device. While creating the user, as we saw right now in the demonstration, there's multiple ways you can sign in with Google, Apple. Since this is a developer product, we also have sign in with GitHub. And you can just do that so that you now have a user. Right now we use the Apple's Face ID to sign in with RainMaker. So we know that, yes, this user is now a RainMaker user. The second part of the onboarding process is the device onboarding, where you have to say, okay, now I am the user, let me try to get a device on the network, right? And this is where you do it. So you say add device, and the phone application will look for a QR code that you can scan. Once you scan the QR code, then the phone application will connect to the device and fetch a list of networks, Wi-Fi networks that are in the range. And then you can configure the configure the password of it. And then the device will firstly connect to the Wi-Fi network. And secondly, there will be an association made which says that this user that signed in with the Apple ID is now authorized to talk to this switch. So
Oh, wow.
that's how the entire onboarding process works, right? And in here, so if you look at the QR code piece also, what we've tried to do is maintain security through the entire process. The QR code is something that we print on the device console itself, and the phone applications can scan it. This is to make sure that your neighbors don't provision your device, right? You have physical possession of the device, and only you can actually configure it to control it.
So I can't prank Tim remotely yet.
Yeah. Nobody's going to take my light bulbs and turn them on and off, or mess with my air conditioner, turn it to heat in the middle of the night. Okay, so now we have, you've got the ability to send these credentials down to the device. You've got a pre-built phone application. You've got cloud services. You have firmware. You've got example code, callbacks, all those kinds of things. What if I have another application that I want to tie into this? Is there a programmatic way to just reach into RainMaker and modify things, or just essentially hook other services to it?
Yes, let me bring up a diagram that explains this better. So what you have here is that what we've looked at is the central stream where the phone application is controlling the device. But if you look at the top, what we've done is provided a Python library, and the Python library encapsulates within it all the communication with the RainMaker backend cloud service. So you can take it and incorporate it into a Python program. So there you see there's a dictionary where we just set the value of brightness to 60 and then pass it to set params, and that's it. Your device parameter is set. Or you can, because it's a library, you can take it and integrate it with other services so that you fetch certain information from some other services that are there on the internet, or you're talking to other devices. It just makes it easy to plug and integrate it with larger projects.
Yeah, I see that for sure. And just like I was saying, firmware engineers sometimes have a hard time adopting the cloud. And I think that cloud engineers sometimes look at firmware as like, oh man, it's really hard to work with that kind of stuff. But this, you've made it easy on both sides. It's C code and callbacks for firmware developers, which are very familiar. And it's, in this case, Python and dictionaries that you just send to the device for cloud developers. So all that plumbing in the middle really kind of bridges the gap between those two groups if they need to write software. It's great.
Yeah, and I saw that you had an Alexa device there. So if I wanted to integrate, Alexa or any voice commands in my app, how would I go about doing that?
We thought about this, and we thought, why not build a RainMaker skill ourselves? So we built an Alexa skill and made it available in the skill store. So you can directly just use that, so you don't have to do any development of skills or anything of that sort.
That's amazing.
Let's actually see this. Yeah, let's actually see this in action. So yeah, here I launched the Alexa app. You go to the skills section there, and you search for ESP RainMaker. It will show you a list of things, but you'll find ESP RainMaker right at the top here. You select this, and then it will show you a few ways in which you can interact with the skill, like turn on the kitchen light or set the brightness. Then you enable, so you click on the enable to use. Once you do this, the skill flow will ask for you to log in. This is where your login, RainMaker login, is now associated with Alexa. We'll go ahead and select the login with Apple here, which is what we used earlier in our demonstration as well. Again, it will use the Face ID, and it will link the skill. That's it. So now your RainMaker login is linked with the Alexa skill, and you can start operating this with the skill. So as part of the, so now let's look at the skill in action.
This is great that I don't have to actually develop
Alexa,
my own. It's
switch on my table lamp.
Yep.
Cool.
That's awesome.
Alexa, switch off my table lamp.
And as engineers, we talk about these things, and architecturally what is happening. But the first time this worked for me, I felt like this was so magical because all I have really done is written those 7 lines of
Hmm.
code, and somehow, Alexa can go turn this thing on and off. It's okay. We say yes, this is how technically it works, but when you experience it, it's just great.
Yeah, and to get it all done together so quickly, like with all these pre-built
Yeah.
applications, again, you don't need to sign up to be a developer on the App Store and submit your own app. You don't need to, onboard yourself into the Alexa ecosystem right away. You can just get started quickly, and then when you want to move to that and you want to build those things yourself, then you can do those. But it really gets things, it really accelerates people to see something happen, which I think is a big motivator for people to keep with it, especially if they're doing it as a hobby.
Right.
You must have tools to flash and debug all this kind of stuff. Are these tools available on all platforms, Mac, Linux, Windows?
Yes, we have all the tools available for Mac, Linux, as well as Windows. These have been supported for quite a few years now, and we've tools for the tool chains for building, flashing the images to the flashing the firmware to the devices, looking at console logs or debugging. All of those tools are baked in and available as part of the SDKs.
That's awesome. And there's a lot of interaction here that you've shown us through the demos, signing in through my Apple ID. So is there capabilities that I could use RainMaker for that wouldn't require me to do any sort of registering, like through my phone or something like that?
Yeah, that is true. So while we looked at these demonstrations in a top-down fashion, all the
Mm-hmm.
software has been written bottom-up, and every layer stands for itself. So if you peel the Rainmaker layer off the top, then we have this ESP Jumpstart, which is an SDK which we separately have, and that SDK in itself has components for network provisioning or OTA firmware upgrades. So all of the common things that you would require. So you say, no, I don't want to register with RainMaker. I just want to do something on my own. You can use these
Mm-hmm.
pieces, or you can even go one layer down and say, oh, I just want to use the web server or the web client by myself. And those kinds of choices and flexibility is available as part of the modules.
Okay.
That is awesome.
Um,
It's nice to be able to
it's
pick and
always,
choose the parts that you can use.
yeah, exactly.
Mm-hmm.
It's good to be able to just take out anything and say, I need to re-implement this for whatever reason. Because like you said, you don't necessarily know what a customer is going to do. They may have a requirement that you guys didn't anticipate, or that they want to support their own way, or they have their own requirements. Like, it's very good to be able to just swap all of those things out when necessary. Now,
Right.
speaking of that, it's easier to do that when the stuff is open source, obviously. And normally I ask people, what components are open source, but everything we've talked about so far, I think, is open source. So maybe an easier question is, what components aren't open source?
That's true. So we've tried to make sure that the agent which runs on the device is open source. The iOS, Android applications are open source. The only thing that is not open source right now is the RainMaker Cloud Backend Service, which is acting as the conduit between the firmware and the phone applications.
Got it. But that's
Got it.
the multi-tenant application that you've got to tie into your application. And like you said, all the protocols are available so that somebody could swap that out if they wanted to do that themselves.
Correct. Yes. So
Yes.
the protocol between the device and the cloud and the phone application is well documented. So it's open that way.
And
Awesome.
can you actually take us through how that works, that interaction between my microcontroller and my phone and the cloud in the middle?
Yep. So okay. So here you see. So initially, as the phone generates, you push a button or move a slider. Step one is
Mm-hmm.
it makes a HTTP put call to this URI, and the call goes to the cloud service. Step two, the cloud service will do the user authentication. It will make sure that you are the user who you claim to be. Once the user is authenticated, step three is the cloud service will make sure that you really have authorization to go and talk to these devices, control them or modify them. And once all of these checks have been passed, then the cloud backend will pass on this request over MQTT to the device. And this will be the step four. So as step four, and the device would be listening for this as a MQTT subscription. So it will be subscribed to the bunch of topics. Here we say the remote topic, and thus the command from the cloud goes back to all the way to the device.
That is really cool how the phone app actually does the authentication for me. So in the diagrams that you have that cloud icon in the middle, and we got a question from Nocturnal Chic. Can you take us through the back end? What are the services in AWS that that cloud part is using?
So what we've done is that we've relied on serverless. So our entire cloud architecture
Yeah.
is hosted on AWS using serverless, development. And we spent many months trying to make sure that this is secure, scalable, but at the same time, it is simple, and the simplicity is not lost as users or developers try to interact with it. So let's actually look at the flow, the same flow that we looked at right now, but in through the cloud backend. So this
Okay.
flow that the phone application to the device, right? So here, step one is that the phone made this HTTP request. We hand it over to the API gateway, which is fronting all our RESTful APIs. The API gateway, step two, is that goes to Cognito. All the users that are registered with RainMaker are registered with Cognito, and it will make sure that the authentication happens through the right authorizers for the request. Once the authorization has succeeded, then we hand over the control to Lambda. As I mentioned, we do not spin any EC2 instance. It's all serverless. It helps us, build faster and not spend a lot of, energy on the DevOps side of things. So what the AWS Lambda is now going to do is refer to other services that we have, like DynamoDB and S3, and it will make sure that the user who is talking to the device really is authorized to talk to the device. And this is a simplified diagrams. There's streams and queues that are doing the plumbing here,
Right.
right?
But this
And
does make
then
it clear
the
kind of what
Lambda.
the general flow is.
Right, yeah. And then the Lambda will eventually hand it over to the AWS IoT, which is the MQTT broker. And the device would have already been waiting for a subscription here. And then as a step four, what happens is that the request actually goes to the device through the publish on that particular topic. And that completes the flow from the phone application all the way to the device.
Nice. Okay. Lots of
Yeah.
cool managed services in there. I love it. Now
Very
I
modern
had another question.
cloud architecture.
Oh yeah.
Sorry,
No,
go ahead,
cruft
Tim.
in there for sure. No, I had a question about provisioning because we talked about it before, and you showed us provisioning early on. But you guys have a new part called the ESP32S2 that has some security components built into it. And I looked in the docs, and you have this notion of self-claiming versus assisted claiming versus host claiming. And I was wondering if you could just talk about those three things.
And this can be. So let me show it with help of a diagram so that this will be clearer. So typically, what happens is that as devices talk to the AWS IoT service, it wants to authenticate all those devices individually, and it expects the X509 certificate-based authentication from all the devices. Now, typically, what happens is that programming a unique certificate in all the devices can be a bit challenging. You accidentally erase the flash, and you accidentally erase the flash, or if you don't want to do that, you bake the certificate in the firmware. But then, if you want to do the second device, then it becomes a problem. So it's hard to manage, and that's the case with just one device, as you rightly pointed out. If you're looking for a number of devices, then it becomes even harder to do that. And what we wanted to do was find out a way to simplify this so that it doesn't have to be so visible as much to the developers. And as you'll see now in the next diagram here, what we've come up with is a claiming service. So, and let's talk about the ESP32S2 here. So we have ESP32S2 and ESP32. The S2 is a newer part. And since we are building a newer part, what we did was that all of these parts have a unique secret programmed in them. And that allows us that once the device is running a RainMaker, then RainMaker will use the secret to identify the device with a separate service called a claiming service. The claiming service will make sure that the device is who it says it is, and then register a certificate with our RainMaker cloud service and vend a certificate back to the device, so that the process of creating the certificate and managing it is completely transparent, and it just happens automatically as the ESP32S2 boots up. Going ahead in the next diagram, we'll see that the ESP32, which was an older part, and when we launched, we just supported S2 because we didn't really have an answer of how do you support this with ESP32, because it didn't have a secret. And then what we did was we came up with the assisted claiming, where the phone application that is running on the accompanying phone will identify and get the certificate from the claiming service on behalf of the ESP32, and then eventually install this certificate on ESP32. So that makes it an assisted claiming, as we like to call it.
Awesome.
The other thing that I have to point here is, sorry, go ahead.
Mm-hmm. Oh, no, I was just going to say, doing that for me actually is a really great, and I don't have to hard code all my credentials and things like that. Sorry. And what were you going to say?
Yep. And no, I was saying, and the other thing that we've tried to do is that here again, keeping flexibility in mind, because there you could say that I don't really want to go through this claiming process. I have my own certificates that I have created, and I want to use those. And we do make sure that that option is also supported, so you can completely bypass claiming and continue to use your certificates and not rely on this entire process.
Awesome. Like, I still more flexibility. Really, I can do what I need to do with this. We have a question from one of the viewers, Tro Roca. Is there an integration with IoT Core for shadow rules and other integration capabilities like SNS or SQS?
Yes. So internally, the RainMaker uses AWS IoT and its features like shadows and analytics as part of the RainMaker. And what happens is this is how we actually get the data that is reported by the device, and then plumb it all the way to the application that is using it. In terms of notifications, that's something that we haven't yet supported today, but that's one of the features that we are working on, where we can directly send notifications out, so that the things of interest are notified and you get those pop-ups or notifications in the right way.
Awesome. Thank you. I mean, it's always good to know what's coming. So I think we go on to our topic, our second feature project. Tim, I think you have a project that you thought would fit in pretty well with this.
Yeah. I think a family member asked me, like I said, we have somebody in the family has autism and OCD, and they struggle with getting out of the shower quickly. They take very, very long showers. And what we looked for was a product that would kind of turn the water off at a certain time, give them a heads up, because the real problem is that they're too focused on doing it right, and that takes them a long time. So having things done automatically for them helps them just get through it. They say, okay, fine, it's the shower's turning off in 5 minutes. They can deal with that, but doing it on their own is really tough. So I thought, great name, RainMaker, to tie into a shower automation project. Could I build this with RainMaker and the ESP32? So I have a little diagram of what I was thinking about initially. And essentially the ESP32 on the left, a solenoid valve that's essentially just, give it a higher load to turn the water on and off. Optionally a flow meter, so I can tell when the shower turns. A display to show status information about the device, and a speaker potentially to play audio alerts, depending on how the person wants to interact with it. And I felt like this this project has to live at somebody else's house and isn't going to live here. So I'm like doing tech support directly. So it needs to have a mobile application. It needs to have all these things. And I was just dreading building all of those components, because I just know it can take a long time and it's a lot of support effort. But now with what you showed me today, I feel like I would be able to at least prototype this project much faster than I could before. And I actually think that you've done some of the setup for me, and I kind of want to see what it would look like.
Yeah, so I was really excited when you talked about this project, and I sort of put some code together for this. So yeah, this is the code here. The top three things are pretty much similar to what we've seen earlier in the switch case. So we create a device called shower and have a name and a power parameter to it. Additionally, based on your requirement, what I've done is created a target time parameter. This is the time for which the shower will continue to run, and this is a read write parameter, and then you can define a range, so like up to 30 minutes. Choose a time between 0 to 30 minutes, and then finally we have a time remaining parameter, which really says if the shower was already on, then how much time is remaining. And this is a read-only parameter that you cannot control. You just see what is happening there, right? So those are the parameters that I created, and then let's look at the application that sort of gets generated for this. So yeah, so that's the application that you see here. So the RainMaker app will redraw itself, and it will say, oh, okay, fine. So this project really has 4 parameters. One is name. The second is the power, which will switch it on and off. The third is the target time, which you can configure, and then fourth, the time remaining is just you get a notification as to what the time is.
Wow. Yeah, this really shows the flexibility of the tool. And
yeah, that's perfect. This is a lot easier than me telling the person, okay, take a Linux laptop and a serial cable and then reflash it like this. No, being able to do all of this stuff through the mobile app is great. And the code, the callbacks and the C code, that makes a lot of sense to me, and the convenience of just having it hooked right into the mobile application and being able to change it on the fly, super important. So I definitely, on a future show, I'm going to work on this project and hopefully highlight this and bring it up again and show the users, show the viewers where I get with it.
Oh, that's very exciting.
So what's next for the RainMaker platform?
In terms of, we have a number of new features that have been lined up for this. Firstly, we've been getting requests about, since we can do remote control, can we also do local control? Because sometimes there might not be an internet connectivity, and if the phone is in the house and the device is in the house, can they just talk to each other directly? So that's one thing that we're working on. Secondly, scheduling, where you can say that my curtain should open up at 6 in the morning and close at 10 in the night. So the scheduling feature is something we're doing. And then thirdly, sharing. So yeah, you can share your devices with your friends or family members. We are also coming up with a Arduino library so that you can do the RainMaker programming, whatever we saw as C code, through the Arduino IDE.
That'll be amazing.
Awesome.
I use Arduino quite a bit, so that'll be very helpful.
Oh, great.
So I think it's time to move on to our All the Tricks segment. So all the tricks. Usually Tim or I are here to provide the tricks, but today, since we have you here, Kedar, to talk about RainMaker, maybe you could share a trick with us and our users.
Yeah, certainly. So I think one of the things that we did not touch upon right now in the demonstrations is firmware upgrades. So many a times, as you are developing projects, you've probably set it up somewhere, or you've created 2 or 3 of these devices and handed them over to your friends. And as developers, you'll continue to add features, and you would want all of those features to be deployed on all these devices, right? So what we've done is, let's look at this CLI command that we've done. So RainMaker also has a CLI, and we've created this mechanism through which you can upgrade these devices. So get nodes is one command for the RainMaker CLI, which says these are the nodes that are associated with your user ID, right? So those are the user IDs. And then you can say that use the OTA upgrade command and say, this is my node ID and this is my firmware executable. And what RainMaker will internally do is that take the executable, send it to the cloud, send a notification to the device saying that there's a firmware upgrade that is available, and the device will fetch it, report back what the status has been, whether the upgrade is successful or no. So by just sitting at your console, you can just upgrade the device, and you get to know whether the upgrade succeeded or not.
Yeah, it'll be really nice not to have to climb up on top of a shelf and pull my device down and plug it in. Can I do this through batches or group updates?
Yes, so that's something that we're working on, where you can
Oh, nice.
create groups of
Okay.
devices, and yeah, you can
Mm-hmm.
create groups of devices and then deploy these. So if you have to do like A/B testing of your firmware, then you can get to do that.
Very cool. Well, I'll definitely be
That
using
will
this
be coming
OTA
in one
feature.
of the upgrade versions.
Yeah,
Yeah.
yeah. Okay, so now let's get into the challenge of things.
Challenge of the things. So, those viewers out there, can you please help Tim with his design? He needs it. Tim is not a designer.
I am definitely not a designer. I should show some examples of my design skills at some point. I really want a good way to, let's see if I can get this on screen quickly. This is a little display that I have. And I really want some way, oh, nothing's focusing. I really want
It's okay.
some good display for this shower project. So I'm looking for inspiration for people. We have a picture that we found of what like a standard kind of clock interface might look on something like this. This looks fine, but if anybody's got any really creative ideas on how we should indicate these things that are, time remaining or status of the device, whatever, I think that'd be really helpful. So feel free to send it to our hashtag all the experiments and let us know what you think it should look like.
Yeah, we would love to hear from you.
And I think that's it. That wraps up another episode. So check the chat stream for resources we talked about during this episode. Thank you, Kadar from Espressif Systems, for joining us today. Really appreciate it.
Oh.
Thanks for having me on the show. This was really fun talking to you and talking about RainMaker here.
When we have a question, why did you name it RainMaker?
Ooh, on the spot.
Oh, well, we were yeah, we were building a product for makers, and given that it is a RainMaker product, given that it does all the things that it can do. So we thought it was an apt name for the product.
Oh, nice. Well, yeah, again, thank you so much for having us. We have lots of great information in the chat stream, in the Twitch stream. So be sure to tune in to our next episode in 2 weeks, October 15th. Please watch for announcements.
And let us know what you thought of the show at hashtag all the experiments. And again, I'm Tim Madison.
And I'm Erin. Thanks again, and we'll see you next time on IoT All the Things
Special Projects Edition.
Special Projects Edition.